Hello friends, in continuation of my previous lecture about non-conventional machining course, today I welcome you all for second lecture on overview of non-conventional processes. In this lecture, we are going to study introduction, then characteristics of traditional and non-traditional processes, what are the needs of non-conventional processes, then classification of non-conventional processes. At the last, we are going to study the comparison between non-conventional processes and traditional processes. Let's go for first part, that is the introduction. As we know that our manufacturing processes can be broadly divided into two parts. First is the primary manufacturing process and second is secondary manufacturing process. Now in primary manufacturing process, it provides basic shape and size to the material as per the designer's requirement. Now for example, casting, forming and powder metallurgy are the primary manufacturing processes. Now secondary manufacturing process, which gives the final shape and size with tighter control on dimension as well as surface characteristics. As we know that material removal processes are belongs to the secondary manufacturing processes, and it having the two group. First is the conventional machining processes. These are the processes mostly remove the material in the form of chips by applying the forces on the work material with a edge-shaped cutting tool that is harder than the workpiece. Now, examples of these conventional machining processes are turning, boring, milling, shaping, broaching, slotting, and grinding. And second group of material removal process are the non-traditional machining processes. Second group of material removal processes is non-traditional manufacturing processes. It is defined as group of processes that remove excess material by various techniques involving mechanical, thermal, electrical or chemical energy or combinations of these energies, but do not use a sharp cutting tools as it needs to be used for traditional manufacturing processes. Examples of these non-traditional processes are abrasive jet machining, electrical discharge machining, electrochemical machining, laser beam machining, etc. Now we'll go for the what are the characteristics of traditional machining process and non-traditional processes. Major characteristics of conventional machining. First is generally microscopic chip formation is there due to shape deformation. Then material removal takes place due to application of cutting forces. And the third is cutting tool is harder than workpiece at room temperature as well as under machining conditions. This is the characteristics of conventional machining. Now we'll see major characteristics of non-conventional machining. First is material removal may occur with chip formation or even no chip formation. For non-conventional machining, there is no need to a physical tool present for the machining. Third is in non-conventional machining, the tool need not to be harder than the workpiece material. And the last is mostly non-traditional machining processes do not necessarily use mechanical energy to provide material removal. They use different energy domains to provide machining. For example, in ultrasonic machining, abrasive jet machining or water jet machining, mechanical energy is used to machine the material, whereas in electrochemical machining we are using electrochemical dissolution for the material removal process. Now, need for non-traditional machining. With development in the non-traditional machining process, currently there are often the first choice and not an alternative to conventional processes for certain technical requirements. Now here I will give some examples which provides non-traditional processes where we can preferably use over the conventional machining process. Now first example is if you want to drill a intricate shaped blind hole, then we can use NTM processes. For example, square hole of 15 mm by 15 mm with a depth of 30 mm. Second, if you want to machine the difficult material, then we can use NTM process. Again, here we can say if you want to machine the inconel material or carbide material, then we can go for the non-traditional processes. Again, low trace grinding, there we can use non-traditional processes. For example, electrochemical grinding is the uh, non-traditional technique where we can use this uh, low trace grinding. Then at last, if you want to go for the deep hole with small diameter, then we can use NTM process. For example, 15 diameter hole with inner and outer diameter 20. That time we can go for NTM process. And last is, if you want to go for the machining of composite, then we need non-traditional machining. Now this is about the need of non-traditional machining. Now we'll see what are the types of this non-traditional machining or unconventional machining, that is classification. Classification of non-traditional machining process is carried out depending on the nature of energy used for material removal. The broad classification is given as follows. First is mechanical processes. Here, erosion of work material by a high velocity stream of abrasives or fluid or both is the typical form of mechanical action. Depending on this mechanical energy used for material removal, there are four types of these NTM processes. First is abrasive jet machining, that is AGM. Second is ultrasonic machining, USM. Third is water jet machining, WJM. And fourth one, abrasive water jet machining, AWJM. This is mechanical energy based NTM processes. Now second part is electrochemical processes, where mechanism is reverse of electroplating and electrochemical energy is used for material removal. Again, in that three types are there. First is electrochemical machining, ECM. Second is electrochemical grinding, ECG. And third is electrojet drilling, EJD. Now third type of this NTM process is electrothermal processes. Here the thermal energy is applied to a very small portion of work surface, causing that portion to be removed by fusion and or vaporization of the material. The thermal energy is generated by conversion of electrical energy. Here again three types are there. First is electro discharge machining, EDM. Second is laser jet machining, LJM. And third is electron beam machining, EBM. And the last type of NTM process is chemical energy based processes. Here most materials are soft boiled or susceptible to chemical attack by certain acids or other agent. In chemical machining, chemicals selectively remove material from portion of the work part, while other part of the surface are protected by a mask. So again, depending upon chemical energy based, there are two types of this chemical process. First is chemical machining or milling, and second is photochemical machining. It is called PCM. This is about the overview of classification of non-traditional machining processes. Now we'll go for important point, that is a comparison between conventional machining and unconventional machining. First point about conventional machining is only mechanical energy is utilized for material removal from the workpiece. In other side, that is for NTM, various forms of energy like electrical, mechanical, thermal, chemical or combination of two or more than two forms of energy are directly utilized for the material removal process. Second point, for conventional machining, materials are removed in the form of chips. Here in NTM, no chip formation. Material is removed in various forms such as tiny metal, particle, ions, molten, or wafer, etc. Third point about the conventional machining is shell deformation is the only phenomena that causes removal of material. Other hand, shear deformation plays an insignificant role in material removing in most of the NTM processes. Instead, erosion, dissolution, evaporation, etc. occur here. In conventional machining, a sharp edge shaped cutting tool having specific geometry and material with its different property is required for cutting action. In non-traditional machining, so-called cutting tool does not exist. However, in few cases, for example, ECM or EDM tool is required and its profile and property must match with the requirement. Next point about the conventional machining is physical contact between cutting tool and workpiece. In non-traditional machining, no physical contact occurs between cutting tool and workpiece. In few processes such as AJM, USM, solid abrasive blades strike the work surface to erode material. Now we'll see the examples of conventional machining like turning, facing, grooving, etc. as well as drilling, boring, reaming. Okay, these are the examples of conventional machining. In non-conventional machining, ultrajet machining, water jet machining, electro discharge machining, ECM, ECHM, PAM. These are the examples. Next point about the conventional machining is conventional machining processes are old. Thus, physics of the process are well understood. So, skilled labor are also readily available at comparatively cheaper cost. But for non-traditional machining, most of these processes are developing. Labor cost is also high due to less number of skilled laborers available in this field. Like this, here I have given more points about conventional machining as well as non-traditional machining. We'll see last point. There are certain shapes that cannot be produced by conventional machining, but NTM processes sometimes become a option for producing such critical shape. So this is about the overview of first chapter, or that is non-conventional machining. Please follow our channel, subscribe it, and please share our videos to your friends. Thank you. Thank you.